Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to be talking about confidence intervals for two means with paired data. Trace metals in drinking water affect the flavor and, in an unusually high concentration, can pose a health hazard. 10 pairs of data were taken measuring zinc concentrations in the bottom and surface water from randomly selected wells in a specific area. We are asked to construct the appropriate 98% confidence interval. Here is our data. This data is paired since each set of data comes from the bottom and the surface of the same well, and we have 10 wells in our sample. First, let's look at our parameter. We're going to let mu sub d equal the true mean difference in bottom and surface zinc concentrations. And we're going to note here that we're going to do the bottom measurement minus the surface measurement. This is a two sample t interval for mu sub d. We have a random sample of 10 wells. The 10% condition is met since we're going to assume there are more than 100 wells in the area. For normality, the central limit theorem is not met since our sample is less than 30, and we don't know anything about the zinc concentration distributions for this area. So we're going to have to make a box plot and justify normality by showing there's no major skewness or outliers and that a t procedure is still appropriate. So let's go ahead and jump over to Desmos and do that now. So here in Desmos, I already have the data put into a table. The x sub 1 column is the bottom measurements, and the y sub 1 is the top or surface level measurements. Now, what we're going to do is look at x1 minus y1, and this distribution here is the data we're going to use. These are the differences, and we are going to be looking at the mean difference here, a confidence interval for these differences. To justify our normality condition, the first thing we're going to do is make a box plot of that data, x1 minus y1. And you can see over here, we're super zoomed in, so let's go ahead and get in there really close. Actually, I'm going to go over here. Got it, Gemini, and change my axes from about, looks like negative 0.5 to a positive, let's go positive 0.5. And you can see my box plot here. It doesn't show any major skewness, and it doesn't show any outliers. So a t procedure is appropriate. Now remember, when we do this on a FRQ, we're going to want to draw this box plot on our paper to show that we actually checked it. Now that we've checked our conditions, we can go ahead and run our procedure. So I'm going to hit plus here, go to inference, and we're running a t-test. And even though this is a two sample, I'm going to use just the list of differences to run the test since it's paired data. So I'm going to put in x1 and y1 here, x1 minus y1, that's important, and hit create test. If I drop down my menu here for confidence intervals, I believe we're making a 98% confidence interval, and you can see that we're going to get 0.027 to 0.128 as our estimate for the mean difference in bottom and surface zinc concentrations. To wrap up our problem, all we have to do is complete our conclusion. We would say here that we are 98% confident that the true mean difference in bottom and surface zinc concentrations is in the interval 0.027 to 0.128. Thank you for watching this video. I'll leave you with this quote by David Brinkley. Have a great day.